In this video, I will review quadratic functions, and I'm going to follow this plan that I derived in one of the earlier videos called precalculus review. So first we're going to discuss the prerequisites, and then we'll discuss the details or the answers to these prompts. If you need more uh, refreshment on what these questions are, please watch um, the video called Precalculus Review. So let's go ahead and get started with the conversation about the prerequisites. And first, let's talk about operations. When it comes to quadratic functions, one has to be able to evaluate quadratic functions and therefore perform operations of addition, subtraction, multiplication, and exponentiation. Students also should be able to compute the following expressions that involve radicals and fractions. A few of them, quite a few of them. So, for example, if you don't know how to, if you're not comfortable with radicals, then you're not going to like working with quadratic functions, and same applies to fractions. Now let's move on. When it comes to different expressions, one has to be able to perform completion of the square. One should be able to factor a quadratic trinomial or declare it as irreducible. One should be able to distribute and combine like terms. All those are what we typically consider as pre-algebraic tasks. And again, if for whatever reason you're not comfortable with any of them, you're not going to like working with quadratic functions. Now, frequently when working with quadratic functions, you may end up with a need to solve a quadratic equation. For example, when you're looking for the x-intercepts. Now, recall that quadratic equation is an equation of this form, and you should know how to solve it in three different ways. Here are the summaries of the three different ways. You should know how to solve it by factoring, you should know how to solve it by completing the square, and you should know how to solve it using the quadratic formula. And we don't have much time in the format of this review to go over each of these methods, so if you need more details, please let me know in the comments. Now that we finished discussing the prerequisites, let's start talking about the not special, but the features of quadratic functions that you should know. So the first one is the form. You should know that quadratic functions can be written in three different ways: vertex form, standard form, and factored form. And the simplest one is when all of them are equal to 0 and a is equal to 1. And this is called or rather, the standard parabola. And its graph can be obtained by simply plotting points. And when it comes to graphing anything but the standard parabola, we have three different approaches depending on in which form the equation is given. Now, if you prefer one of them over the other two, then you should know how to convert each of these forms into any other two. So that way you can graph your parabola, regardless of which form it is given to you. So again, this is just a summary. I'm not trying to reteach you any of this. So if you have any questions about any of this graphing methods, please let me know in the comments. Now that you graph the parabola based on the shape of the graph, it can be classified as one of the following six uh, images. So when the leading coefficient is positive, your parabola may have two x-intercepts when its vertex is below the x-axis. You may have one x-intercept when the vertex is on the x-axis, or you may have no x-intercepts when your vertex is above the x-axis. So when the parabola is upside down, the same three cases, you may have two x-intercepts, or you may have one x-intercept, or you may have no x-intercepts. So these are your possible cases, or rather possible shapes in regards to the number of x-intercepts. Now that you have the graph of your parabola, of your quadratic function, you should be able to discuss the domain and the range. The domain of quadratic functions are always the entire number line, so there are no constraints on when you're adding, subtracting, multiplying, exponentiating. So that's why the domain is all real numbers. Now, the range of the quadratic function depends on, again, the combination of two things. Whether the leading coefficient is positive or negative, and where the vertex is. So in general, if the leading coefficient is positive, that is, the parabola opens up, the range is from the y-coordinate of the vertex going all the way up. And when the coefficient is negative, the range is starts at negative infinity and goes all the way up to the y-coordinate of the vertex, as it is shown in this table. Now, to find the y-coordinate of the vertex, you can use the skill that we acquired in this slide. So given the equation, you always know what that where the vertex is and both of its coordinates. So here in the table below, I provide you with more details, but again, if you are familiar with the graphing methods, then this table is trivial to you. Let's talk about intercepts. To find the y-intercept, you simply have to evaluate the quadratic function at 0. To find the x-intercepts, you have to set the output equal to 0. And by doing so, you end up with the quadratic equation, which you should know how to solve, no matter which form it is given to you. So here I provided some general formulas, but again, I would advise you against memorizing these formulas, but just rather suggest to understand the relation between quadratic functions and quadratic equations. Here we can develop the criteria for when your quadratic function has or doesn't have x-intercepts. Again, it all depends on the combination of these values, and analytically you should be able to use them and visualize the picture and decide whether you have 0, 1, or 2 x-intercepts. So, for example, when your graph is given to you in factored form, you should know that you will have only one x-intercept when R and S are the same, or in this case, when the discriminant is equal to 0, or in this case, when k is equal to 0. So these are just different sides of the same coin, and you should be able to see this through, like, analytically. However, if you need more details on any of this, please let me know. Now, it's easy to know that quadratic functions do not have asymptotes. It is also trivial that quadratic functions are continuous on their entire domain, which is from negative infinity to infinity. However, just like the absolute value functions, quadratic functions have they switch from increasing to decreasing behavior, or from decreasing to increasing behavior, depending on what the coefficients. So again, it all depends on where the vertex is and whether the leading coefficient is positive or negative. So if your parabola looks like this when a is positive, or like this when a is negative, you should be able to determine the vertex and describe where the function is decreasing, increasing, or increasing and then decreasing. Now, down below here, I provided you with the summary depending on the type of the equation in which the quadratic function is written. However, again, I'm suggesting you not to memorize this, but rather understand what does it mean to increase and decrease, and use your analytical skills rather than memorization. Now, it is important to know that parabolas are not one-to-one functions, and therefore they do not have inverses. However, each branch of a parabola, and by branch I mean if this is your parabola, branch like this, like if we cut it right here in the middle, then this is what I refer to different branches. So each branch is one-to-one, and for each of these branches, you should be able to find the inverse function by following this standard procedure in which you start with the original function, then swap x and y, and then isolate your y, and at the end you end up with what we call the inverse function. So again, each of these branches has its own inverse function, which is a radical function, which we will discuss later. Now, when it comes to symmetry, quadratic functions do have what we call the axis of symmetry, but in general, we may not be able to classify it as even or odd. So we only call quadratic functions even when the following conditions, one of the following conditions, I guess they're all satisfied at the same time, right? So when this is true, then the function is even. Otherwise, the function is not even, but it still may have that symmetry. Remember that. Even is just having that special symmetry with respect to the y-axis. Now, this table provides you with, again, more details related to the equation of the axis of symmetry in relation to the vertex. You can easily see the pattern. Axis of symmetry passes through the vertex. So the equation of the axis of symmetry is always x in the form x equals the first coordinate of the vertex. Now, what are some special features of parabolas? Unlike linear functions, which didn't have turning points, but like absolute value functions, quadratic functions do have turning points, and therefore they have what we call minimum or maximum. And whether it's a minimum or maximum depends on the leading coefficient. So we can call this a special feature, but parabolas, unlike absolute value functions, have many more applications, which we will discuss later. Now, when it comes to applications, it's very important to be able to find the equation. And how do we find an equation of a parabola? So again, the idea is to look at the number of parameters. And if you look at any of the three forms, so this is standard form, this is a vertex form, and this is factored form. In all three of them, there are three unknown parameters. So what does that mean? That means we have to have 3 points. So through any 3 points, there is a unique parabola. And to find it, we set up a system of equations. And usually, if we're doing it this way, we're looking for the equation in standard form. And then in that case, we're going to end up with a system of 3 linear equations in which a, b, and c are the unknown variables. So this is if 3 points are given. However, sometimes we are given something else. So if you are given the x-intercepts, and then you should be able to find the equation in factored form relatively easy if an additional point is provided. Then that additional point can be used to find this leading coefficient a. On the other hand, if vertex is given, you can pretty much immediately find the equation in vertex form. However, an additional point can be used, or some other additional piece of information can be used to find the leading coefficient a. If additional point is given, then this is how you find A. So I don't suggest you memorize these formulas, just want you to understand the relation between the number of unknown parameters and how many pieces of information are required to find the equation of the function. Now, when it comes to applications, as I said, unlike absolute value functions, quadratic functions have many applications, and one of which is using parabolas to describe trajectories of projectiles. The other one is, for example, Galileo discovered that if you just look, so again, we're not throwing, so what's the difference between what Galileo discovered and trajectory of a projectile? Trajectory of a projectile, it's kind of the path of anything that you throw at an angle upward. Now, Galileo discovered that if you just take an object and you throw it up, it will go up and down, right, naturally. So if you look at the height function, or how far this object is from the surface, this will be a quadratic function. That's what Galileo has observed, which is pretty cool. I guess he lived in very exciting times. Or maybe not. Who knows? Let me know in the comments what you think about Galileo and the times that he lived in. This concludes my review of quadratic functions. Again, due to the format, it wasn't meant to be very detailed. So if you need any additional details about any of the slides, please let me know in the comments.